same proportion, which means that B has to have the same proportion as the smaller B. And you can solve that, and this ends up being, what is this? This is 6.25, right? 6.25 equals B over 3, and then multiply both sides by 3, and then this becomes 18.75 meters is equal to B. Does that look right? Yes?
Just to clarify, you could also do the ratio of the side lengths in their own triangles, right? So you could have like, I did 4 over 3 equals 25 over B.
Yeah, that's the same as this, but upside down, right? Or,
Well, no,
isn't that
because
the
it's
same thing?
4 over 3 equals 25 over B.
Yeah, you can do that. Yeah. So any proportion, as long as they're related proportions, can work too. Okay. Any proportion works. There's a more direct way. Rather than finding the proportion, you can use your calculator's sine, cosine, and tangent functions, and those buttons, if you've used them before, actually produce the ratios. So if I were to put in, for example, if I were to put in tangent of 37, put tan 37 into your calculator, then what happens is that's going to give you a number, and that number is the ratio of these two sides. Oh. You're senior. Is that what this is? Yeah. So you have an important minute. Yes. Yeah. So when you push tangent, that number gives you, I'll do this later, it gives you the actual ratio of those two sides. Now, let's see where I have it. That's the same thing I showed on the board up there. That's how you do that using proportions. I want to get past proportions. I don't want you to be thinking that we have to solve two-dimensional problems by doing triangle ratios over and over again. There's actually a much more direct way of getting the answer, and we're getting to it, so trust me. All right? So we're going to move on and take a look at this right here. So now we're going to introduce the actual true definitions of what sine, cosine, and tangent are. So there's no meaning to what sine means. Sine does not mean anything other than SIN. It's just a mathematical symbol that represents a ratio of two sides of a right triangle. And sine is O over H. So in our triangle, O stands for opposite of the angle, H stands for hypotenuse, and A stands for adjacent to the angle theta. Now, if you type in and compute tan 37, use your own calculator or use my yellow calculators, and just punch in tan 37. You should get about 0.75. So please check that quickly. I got like a nod of yes. If you don't get 0.75, then what happens is that your calculator is not in what we call degree mode. It has to be in degree mode. If you use your own phone calculators, then you have to make sure your phone calculator is using degrees, not any other system of measuring angles. There actually is another system called radian that we're not going to use. We do use it later on in the class, but not right now.
No.
So when you push tan 37, you need to get about 0.75. Right? Now, think about that for a second. 0.75. In our other triangle, remember, this side was 3, and that side was 4, wasn't it? So what's 3 divided by 4? 0.75. So every right triangle that has an angle of 37, the ratio of one leg to the other is 0.75 if it's in that angle right there on the bottom. If you do cosine of the angle, then you get the ratio of the A to the hypotenuse. If you do the sine of the angle, you get the ratio of O to H. So that's what sine, cosine, and tangent give you on your calculator. It gives you the decimal ratio of two sides of a triangle. And remember that by using the mnemonic. Yes?
Tangent's written wrong.
Yeah, it should be O over A.
Okay.
Thank you. So it should be so, I gotta fix that now because I'll not fix it later. So give me this moment to do that quickly. This should be an A. Come on.
Do you know how to put a calculator in degrees now?
No. I would convert it to radians.
There you go. Fix.
But I don't know. Doesn't either.
So the common mnemonic that's taught almost everybody who learns about right triangles, every teacher that I know has ever done it, this uses the word SOHCAHTOA as a way to remember those relationships. Now, we're gonna actually use this for another problem. Ready for it? Here we go. Let's look at this one. This one's fun. This one's a challenge.
Oh.
Now, I'll let you like sweat it out for a minute or two, okay? There's not a right triangle, so don't think you're not going to be using the Pythagorean theorem for that triangle.
No.
In fact, some of you might have heard of the law of cosines. We're not going to do that. You could if you want to. If you know how to use the law of cosines, then by all means do it. We don't need to.
Excuse me.
Yeah.
Do you know how to put a calculator into degrees?
Yeah. So push second, and then I'm sorry, just push mode. There should be like a mode button on top. And then now you see like there's a whole bunch of parameters. Just scroll down and select where it says radian degree. Just make sure you highlight the degree.
Okay. And then enter.
And it should be now, it should be blocked as black.
There we go.
Now it's gonna be in degrees.
Okay.
All right. So, then I have a clue how to do this. I'm not surprised. How many of you have heard of? So Andrew, how would you do it since you raised your hand?
Well, I don't know exactly how I would do this, but I think that what I would start by doing is maybe splitting this into two right triangles.
Very good, very smart.
Because this right now is almost, I don't know how to deal with a
Non-right
triangle
triangles, yeah.
A triangle as complicated as that. So, I would split it perpendicular to line R, I suppose, so that it intersects with the like the point that
I know what you're talking
I don't know
about.
how to describe it, but
Yeah,
like
I
I would
understand
split it
what
into
you
two right triangles,
Yeah,
and then I would try to solve for the side length of one, and then solve for the side length of the other, and then add them together.
Okay, all right, Jack.
I think this would work. I think what you do is first you have like 7 divided by 5 as, so that's going to be tangent, right? So I can't remember if you plug it
You
in.
can't do that.
You can't do that?
Tangent
Oh.
only works if it's a right triangle.
Oh,
It's not a right triangle.
I didn't think about that.
Yeah.
Okay.
So Andrew's on the right track. So I'll try to paraphrase what Andrew said. He wants to take those two vectors, those two red arrows, those two solid red arrows, 5 and 7. He wants to make them into right triangles. That is actually how I did it. And the reason why you do it that way is because now you still just need SOHCAHTOA to solve the problem. If you try to solve that triangle, you need a couple more complex trig rules called the law of sine and the law of cosines, which from what I see in your faces, you never heard those before, right? So that's, or have you? Ken, have you heard them before? Or in math maybe? Or it's not something that usually, from what I've been told from math teachers, that in typical geometry units, when you do right triangles, they start off with SOHCAHTOA, then you get to other triangles, they introduce the law of cosines, law of sines. But that's not a guarantee universally taught by all teachers. So we're gonna stick to right triangles so that we don't learn anything more than we have to. So here's how it works. First of all, just to give you the basic physics premise here. If I wanna get from here to there, well, I can walk this path, right? But I can also walk this path and get to the same position, right? So if I did this path and that path, is that gonna get me the same displacement between start and finish?
Yes.
Yes. So that's why it's called displacement. The displacement only depends on the shortest distance between 2 points. I can also do this path too. I can go bam, 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 and get to the same point, right? So that's what Andrew's idea was, to do this. Right? So watch this. We're gonna walk that way first, and then that way. And now we can find the lengths of those two sides. Now, there's the SOHCAHTOA. Well, sine and cosine, you can see it's 60 degrees. What should the value of a y be? Y being the upward arrow, the purple one. Can you solve that for me right now? So you gotta punch into your calculators, and you can use my yellow ones, they have the sine functions on there. To solve for ay, sine 60 equals ay over 5
adjacent.
Yeah, sine 60 should be about 0.707.
Huh.
So you would take sine 60 and then multiply that by 5, and that gets you the purple vector.
How?
Yeah.
And then you would do cosine 60, which is exactly 0.5.
How is
then-
this solving for R?
We're not there yet.
Oh,
We
okay.
will eventually get to R.
Oh, no, I see it actually.
Yeah, we're
Never
one
mind.
step at a time. So if you get those solutions, I think the next answer comes up. You can do it for the second triangle too. So at this point, I want you to find the lengths of the red and the green, or the purple and the green vectors. To do that right now, take a moment to do that.
What is the
Make sure that everybody at your table agrees with each other, that you get the same answers for AY and AX and the same answers for BY and BX.
person walks 5 miles? East of north. Oh. Oh, that's annoying.
Does anybody have an answer for AY right now?
You do
Sure, Carl, what is it?
12.33 miles.
This one?
What?
12 point what?
4.3.
West
4.3. That
east.
sounds about right.
How? It walk. Oh, 30 degrees. Oh.
Yeah. Does anybody else disagree with that? or-
Oh, that makes sense
Fine.
now. Okay.
And do you get 2.5 for that one?
I think that makes sense now.
I'm just gonna go ahead and write it out up here just to see that it works. Let's
Oh,
take
arc sine. That's
sine
your
60
sign. It's getting confused.
equals AY over 5. So sine 60, you should get about 0.707. Do we all agree with that?
Like I get how to make them.
You're not getting 0.707 in your calculator, that means your calculator's not set up properly. What is the Y?
That's what it is.
Y means purple.
Okay.
So here's AY,
Without like testing.
AY, and AX. So that's why I made them green, X is green, and Y is
It'll
purple.
tell you, it has to tell you one of the angles, because otherwise you can't solve the problem.
So that equals AY times divided by 5. Now multiply both sides by
So they're
5.
never gonna give us a test where
That means AY should be about 4.33 miles. So we have to all agree on that if we're gonna move on.
I agree.
Okay, I agree. All right. And let's go ahead and clear that out.
What about, wouldn't Pythagorean theorem say though, that it'd be like 4 and 3 because A squared plus B squared equals B squared?
So, well, yes, you're talking about these, like this and that, right?
Yeah.
Yeah. But we didn't, we could never have used Pythagorean's theorem to get both those sides because you have just A, right? Or you have, this is C, right? That's C. You don't know A nor B. You know either one of them. Oh, I should talk about, if I find out what AY is, I can then use the Pythagorean theorem to find X. You could, and you would get 2.5. Okay, no question. But the question you want to ask yourself is that easier to do? Is it easier to go, okay, we're gonna go C squared equals A squared plus B squared, now we're gonna put in our 5 squared equals A squared plus 4.33 squared. Do you think that's easier than doing cosine 60 equals AX over 5? Which one of those two do you think is easier to solve? Yeah,
Where'd you get
so
the
it's your
poison?
choice, pick your poison. I do not have any qualms about that. Just, you know, if you prefer to use the Pythagorean theorem at any time possible, by all means do that. As long as you get the correct answer. As long as the math and the physics is correct. Okay. All right, now that step gets us our 2 triangles. Right?
Oh, okay, now
So
that
now we're
makes
gonna move
sense.
on, and we have this now, 3.5, 6, no, that's the second triangle, right? It's that right there. Okay. So we only, yeah, so that's the same answers as before, right? The same answers as before. Now we're gonna do this, okay? Okay. And so let me go back, if you're taking a picture of that, take a picture of that if you want to. So what you're gonna see next is, what if I took this green one and that green and made one long green one all the way over there? What's that gonna equal?
8.56.
It should be 8.56. And what should the purple one be? You take the bigger one on the bottom and small on top? What those categories?
7.83.
Good. So you're seeing we're adding the purple arrows together and adding the green arrows together and getting a bigger right triangle, the one for the hypotenuse, the red dotted line. See that? Now, there's our answer, 7.4 miles. And all we used was the right triangle. Even though we started off with a non-right triangle.
It's arc.
And then what's the angle? Can you find the angle theta? You remember
We have both.
that here we have, this side is equal to 7.83, and this side is equal to 8.31. So katoa, which one of those gives us the ratio of opposite to adjacent? Somebody else, they're ready. Which one is it? So katoa, so sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent, toa, opposite over adjacent. So which one's it? So would
Oh,
be,
no, it's way
that's not so, not so. So toa, so OA.
Yeah.
O stands for opposite, A stands for adjacent.